Hello everyone, welcome to my new video. So today I am going to discuss an interesting sequence problem of NBHM 2023. So the question says that let f from R to R be a function such that f of y is basically equal to y square plus y divided by 2. Given a real number x, we take it to be the zeroth term x0 of the sequence xn, and xn is defined by the induction f of xn minus f of xn minus 1, and it is asked that for which real number x the sequence convergent. Okay, this is the actual meaning of this question. So question seems to be lengthy, but the actual meaning is that it is a recursive sequence, and the recursive sequence is basically xn plus 1 is equal to xn square plus xn divided by 2, and we have to find out for which initial term, I mean for which term x0, for which value x0 the sequence xn convergent. Okay, so let's start the solution. So the sequence is basically xn plus 1 equal to xn square plus xn divided by 2. So first we observe that if the sequence converges to x, then what can be the value of x? So assume that xn converges to x, then definitely xn plus 1 also converges to x. So it implies that x equal to x square plus x divided by 2. That is x square equal to x. That is x equal to 0 or 1. So the possible limit of the sequence, if the sequence xn convergent, then possible limit of the sequence is either 0 or 1, right? So if x0 equal to 0, then x1 equal to 0 plus 0 divided by 2, which is also 0. Similarly x2 equal to 0. Similarly for all n, xn equal to 0. So it is basically a constant 0 sequence. So definitely it is convergent. Similarly, if x0 equal to 1, then also xn equal to 1 for every n. So it is a constant 1 sequence. Now assume that if x0 belongs to 0, 1, if x0 belongs to 0, 1, then definitely x1 also belongs to 0, 1, because 0 less than x0 less than 1. This implies that 0 less than x0 square plus x0 by 2 less than 1. So definitely it will imply that x1 is less than 1 and also x1 is greater than 0. Similarly for every n, xn belongs to open interval 0, 1. Now observe that xn plus 1 minus xn is basically xn square plus xn divided by 2 minus xn, which is equal to xn square minus xn divided by 2, and that is xn into xn minus 1 by 2. Okay, now since xn belongs to 0, 1, then xn minus 1 is always a negative term, but xn is a positive term. So here we have a product of negative term and a positive term, that is always less than 0. Hence xn plus 1 is less than xn for every n when x0 belongs to 0, 1. So when x0 belongs to open interval 0, 1, xn is monotonically decreasing, and also xn is bounded below by 0. Then by monotone convergence theorem, xn is convergent. Then what we get? We actually get for every x, I mean for every initial choice of closed bounded interval 0, 1, this sequence xn is convergent. Okay. So it is obvious that when x0 equal to 0 and x0 equal to 1, it is basically constant sequence, and when x0 belongs to 0 open interval 0, 1, then for every n xn belongs to open interval 0, 1, and since for that case xn is monotonically decreasing and xn is greater than 0 for every n, that means xn is bounded below by 0 and xn is monotonically decreasing. So we know that every monotone decreasing sequence which is bounded below is convergent. So definitely for initial choice of x0 belonging to open interval 0, 1, xn is convergent. Now come to the next part. Let assume that x0 greater than 1. Then definitely x0 square greater than 1. Then definitely x0 square plus x0 greater than 2. Then definitely x0 square plus x0 divided by 2 greater than 1. That means x1 greater than 1. Similarly, recursively we get xn greater than 1. Now xn plus 1 minus xn is basically xn into xn minus 1 divided by 2, and since xn greater than 1 and xn also greater than 0, that will imply that this term is positive, then xn is monotonically increasing. Now xn is monotonically increasing. Okay, so if xn is monotonically increasing, that means if it converges, that means if it converges to a limit which is greater than 1, because each term is greater than 1 and xn is monotonically increasing, so definitely if xn converges, then it must uh, go to a limit which value is greater than 1. But we already seen that if xn converges, then value of the limit must be either 0 or 1. So that's why when x0 greater than 1, it cannot converge. Okay, so this is a nice thing. Now come to the next part. If x0 greater than 0, then x1 is basically x0 into x0 plus 1 divided by 2. Now observe, there is two cases. If x0 less than minus 1, then both term are negative, so product of these two term is actually positive. So if x0 less than minus 1, then x1 become positive, and if x0 greater than minus 1, then x1 become negative. So assume that x0 belongs to minus 1 comma 0 open interval, because we already seen that for x0 equal to 0, it is convergent, right? So I assume that if x1 belongs to open interval minus 1 comma 0, then x1 is also less than 0, because this part is negative, this part is positive, so this is less than 0, and similarly x2 is less than 0. Now xn plus 1 minus xn is basically xn into xn minus 1 divided by 2. Now xn is negative, xn minus 1 is also negative, product of two negative terms is positive, so xn plus 1 minus xn is always greater than 0. Then xn is monotone increasing sequence, and it is bounded above by 0, because x0 is less than 0, x1 is less than 0, x2 is less than 0. I already assumed that x0 belongs to minus 1 comma 0, so when x0 belongs to minus 1 comma 0, x1 also less than 0, x2 also less than 0, so on, so xn also less than 0. So recursively we can say that xn is bounded above by 0, and since xn plus 1 minus xn is greater than 0, that means xn is monotone increasing and bounded above. So xn is monotone increasing and bounded above by 0, so that will imply that xn is convergent. Okay, so for x0 belongs to minus 1 comma 0 open interval, xn is convergent. Now assume that x0 equal to minus 1. Okay, so first assume that x0 equal to minus 1, then x1 equal to minus 1 square, which is 1, minus 1 divided by 0, sorry, divided by 2, which is equal to 0. So x1 equal to 0, and whenever x1 equal to 0, then x2 equal to 0, whenever x2 equal to 0, x3 equal to 0, so on. So xn becomes the sequence minus 1 comma 0 comma 0, so that is eventually constant sequence 0, so definitely xn is convergent. Now when x0 less than minus 1, when x0 less than minus 1, so x0 is less than minus 1 and x0 plus 1 is also less than minus 1. I mean x0 plus 1, sorry, when x0 less than minus 1, then x0 plus 1 less than 0, so both are negative, so product of two negative terms is always positive, so x1 greater than 0. So x0 less than minus 1 imply x1 greater than 0, and whenever x1 greater than 0, x2 also greater than 0, as similarly recursively we can say that xn greater than 0. Now see that xn plus 1 minus xn is basically xn into xn minus 1 divided by 2. So when divided by 2. Now in this case, if you observe this equation, I mean sorry, if we observe this relation xn plus 1 minus xn, that is equal to xn into xn minus 1 by 2, and if x0 belongs to minus 1 comma 1, so I can write down it that since when x value of x0 is very close to minus 2, then value of x0 square is very close to 4, and that is greater than 4. Okay, that is also greater than 4. So value of x0 square plus x0 divided by 2 is basically less than 1. Okay, you can check by taking value of x0, say minus 2.00001, say very small value which is near to minus 2, and check this. So this happens, right? So then x1 is basically minus 1 comma 1, and similarly xn is also belongs to minus 1 comma 1, and we already see the result that xn is convergent when this is inside this interval, so xn is convergent. Okay, now when x0 equal to 2, x1 equal to 1, x2 equal to 1, and so on, so xn is basically eventually constant sequence 1, so definitely xn also converges. Now the case is when x0 less than minus 2. Okay, so when x0 less than minus 2, x0 square greater than 4, and my claim is that x0 square plus x0 is greater than 2. Okay, so let's start. When x0 less than minus 2, say x0 equal to minus 2 comma my x0 equal to minus 2 minus epsilon, where epsilon greater than 0. I can take, then x0 square is basically minus 2 minus epsilon whole square, which is 2 plus epsilon whole square, which is 4 plus 4 epsilon plus epsilon square. Then x0 square plus x0 is basically 4 plus 4 epsilon plus epsilon square minus 2 minus epsilon, which is same as 2 plus 3 epsilon plus epsilon square. Now since epsilon is positive, 3 epsilon plus epsilon square is also positive, so 2 plus 3 epsilon plus epsilon square is definitely greater than 2, strictly greater than 2, right? Then x0 square plus x0 divided by 2 is always greater than 1, then x1 greater than 1, and we already seen that if x1 greater than 1, then x2 greater than 1, and similarly xn greater than 1, then xn is monotonically increasing, the same situation arises, and definitely xn is divergent. So ultimately, for which value of x0, I mean which value of x0 it is convergent, it is this one, closed interval minus 2 comma 1. So this problem is actually very basic problem. It is just the use of monotone convergence theorem. I mean, if more sequence monotone increasing and bounded above, then it is convergent. If sequence is monotone decreasing and bounded below, then it is convergent. It is just that result, but the question seems to be lengthy, and but the question is very much interesting. Okay, you have to observe the value, what can it be x0, and you have to conclude these things. Okay.